Lesson 10.2, Hypothesis Test for a Population Proportion. The objectives for this lesson is to be able to explain the logic of hypothesis testing, test hypotheses about a population proportion, test hypotheses about a population proportion using the binomial probability distribution. So let's first start off with defining statistically significant. This is when observed results are unlikely under the assumption that the null hypothesis is true. Say the result is statistically significant. When the hypothesis is statistically significant, we reject the null hypothesis. A criterion for testing hypotheses is to determine how likely the observed sample proportion is under the assumption that the statement in the null hypothesis is true. The likelihood of obtaining a sample statistic can be attained either through simulation or through the use of the normal model. Both approaches give similar results. Essentially, simulation represents an empirical probability and the normal model represents a classical probability. Remember, with empirical probability, we estimate the probability of an event by conducting an experiment over and over, whereas classical probability obtains probabilities through counting techniques. We will define the p-value. This is the probability of observing a sample statistic as extreme as or more extreme than one observed under the assumption that the statement in the null hypothesis is true. So how do you determine whether the null hypothesis should be rejected using the p-value approach? If the p-value is less than alpha, we reject the null hypothesis. If the p-value is greater than alpha, we do not reject the null hypothesis. We cannot say accept, we say do not reject. Here, the figure further shows the idea behind the p-value approach. The distribution in blue on the left, so that in blue they refer to the line, shows the distribution of the sample proportion, assuming the statement in the null hypothesis is true. So it's equal to 0.5. The sample proportion of 0.54 is too far from the assumed population proportion of 0.5. In other words, obtaining a sample proportion of 0.54 or higher from a population whose proportion is 0.5 is unlikely. Therefore, we reject the null hypothesis that p equals 0.5 and conclude that p is greater than 0.5. We do not know what the population proportion of registered voters who are in favor of the policy is, but we have evidence to say that it is greater than 0.5. So this can be written as H null, where p is equal to 0.5, and the alternative is p greater than 0.5. We're rejecting the null, so we're going with the alternative.